This is the video for section 4.7 in pre-calc. We're going to start with trig inverses, but today we're going to finish a little bit from 4.3 that we didn't quite get to. So, using one trig ratio to find the others. We need to find the cosine and tangent by using the given information to construct a reference triangle. So we start out with the sine of theta equals 3/7. Well, I don't know for sure what quadrant my triangle is supposed to be in. So it talks about that the tan has to be less than 0. Well, remember that tangent is sine theta over cosine theta. And if that has to be less than 0, and my sine is given to me as positive, then the cosine part has to be negative. Which means I'm talking about quadrant 2, where my cosine, or my adjacent side, can be negative, my x can be negative, and my y is positive. So when it gives me the sine of 3/7, sine, remember, theta is here, sine is opposite over hypotenuse, so 3 is my opposite side, 7 is my hypotenuse. Now I need to use my Pythagorean theorem to find the other side. 49 equals b squared, plus 9, take away 9 from both sides, you get 40 equals b squared. B equals the square root of 40. So this side, and remember it's cosine along here, so it's not just the square root of 40, but because x is negative here, it has to be negative square root of 40. Remember when we take the square root, we get plus or minus? Well, up to this point, normally we've been talking about the positive side. But in this case, I need the negative. So when I talk about my cosine of theta, it's got to be adjacent, so negative square root of 40 over my hypotenuse of 7. The tangent, remember, had to be negative, and it still is, which is opposite 3 over adjacent negative root 40. If I multiply everything by square root of 40 over the square root of 40, I get negative 3 square roots of 40 over 40 for my final answer. But it's very important that we understand what this part of the question is telling us. That tells us what quadrant we were in. Last year in Algebra 2, they told you what specific quadrant. Now you have to be able to understand the trig in order to figure it out. Let's do another example. Alright, here there are two student examples. We'll talk about the second one, and I will leave the first one to you. So the cotangent of theta is undefined. Remember, cotangent is sine theta over cosine theta. And it's undefined, which means that the cosine has to equal 0. So the sine can be anything, but cosine has to be 0. So I'm talking about one of my quadrants. Secant is also negative. Well, secant is 1 over cosine theta, and that has to be negative, which means that the cosine has to be negative. Now, we made a mistake here in the fact that we're talking about cotan, and so cotan is not sine over cosine, it's cosine over sine. Which means, if it's undefined, that the sine is 0, which means my cosine is left to be a negative 1, because the only way I'm going to get a sine of 0 is if I am on one of the axes, and this said the cosine had to be negative. So, where am I at negative 1, 0? That happens right here. Okay? So this is my point, negative 1 comma 0. So when I find the cosine and the tangent, I know that the cosine of theta had to equal negative 1, and the tangent of theta, which is sine over cosine, or 0 over negative 1, is going to be 0. So there's the answer to my two questions. Go ahead and pause the video and attempt number 1 on your own. Come back and check your answers. Alright, go ahead and check your work. Now, notice, I know that secant of theta equals 3, which means 1 over cosine equals 3. Well, to get cosine by itself, we find out that the cosine is the reciprocal. So the reciprocal of 3 is 1/3. That gives me my cosine part. Right? So I know that if cosine is positive and sine is positive, I have to be in quadrant 1, because x and y are both positive in quadrant 1. Then draw and label my triangle. I find out I need to know my adjacent side. Whoops. My adjacent side is 1, my hypotenuse is 3, so my opposite side is the square root of 8, so then I use that to find my tangent. Now, I did make a mistake earlier, but have since corrected that, so please make sure you double check your work again. Now, let's move on to inverse functions. So inverse trig functions, why do we want to talk about them? Because they help us to undo any trig function. How do I undo sine? The inverse sine, or the arc sine. How do I undo cosine? Arc cosine. We use them to find the angle measures, not the side lengths, and that's very important that we use the inverses to help us find the angles. So, when we talk about inverses, in order for something to have an inverse, it has to be 1 to 1. Well, in order for it to be 1 to 1, it has to pass the horizontal line test, and our trig functions do not do that because they repeat over and over and over again. But if we talk about them on specific domains, then we can use them. So we have to make sure that when we're doing these questions, we think about where does the sine and the cosine and the tangent actually live. So the sine has a domain from negative pi over 2 to pi over 2. Well, remember on our unit circle, up here is pi over 2, so down here is going to be negative pi over 2. So if it has this domain, that means it lives in this half. So when I talk about the inverse sine, I can only talk about it in quadrant 1 and quadrant 4. When I talk about the inverse tangent, it has the same domain. So it only lives in quadrant 1 and quadrant 4. So when I'm looking for solutions, I'm looking for angles. When I'm doing the inverse, I'm only going to look for those in those two places. But cosine's domain goes from 0 to pi. So cosine lives up here, from 0 to pi. Alright, because here is pi, and here's my 0. So cosine lives in quadrant 2 and 3. Now, what does that mean and how does it help me? Well, next question is evaluate without a calculator. So last class we talked about how do I work the problem forward? How do I find the sine of pi over 2 pi over 3 using my calculator, or the cosine of pi over 6, or the tangent of 60 degrees without my calculator? Well, now I want to know the angle measure. So remember, I'm talking inverse sine of square root 3 over 2. That means, where is the y coordinate equal the square root of 3 over 2? Well, if I look at my unit circle, here is a y of the square root of 3 over 2, and here is a y of the square root of 3 over 2. How do I know which one's my answer? Well, this is where my domain comes back into play. This one is in the first quadrant. This is quadrant 1, 2, 3, 4. Remember, sine only lives here in quadrants 1 and 4, so this has to be the one I'm looking for. Well, this happens at 60 degrees or pi over 3. So on my unit circle, I'm looking for the coordinate, and then from there finding the angle. I'm not looking at an angle and then finding the coordinate. We're working the problem backwards. Alright? Now let's look at the next one. Now I want to know, where is the cosine equal to negative 1/2? Remember, cosine lives up here in quadrants 1 and 2. It's a negative 1/2, which means I'm probably over here in quadrant 2. So I'm looking for an x coordinate of negative 1/2. Well, here it is. And this happened at 2 pi over 3, or 120 degrees. And in most cases, we will ask you for both the radian and the degree measure. So please make sure you're paying attention to both of those. Alright, let's try another couple. Inverse tan. Inverse tan is hard because remember, it's sine over cosine. So where can I look in order to find out that the square root of 3 is in my answer? Well, with tan it's a little more difficult. Remember that tangent lives in quadrants 1 and 4. So I'm looking for a place where I'm going to end up with the square root of 3. Well, here I have a square root of 3 somewhere in my point, and here I have a square root of 3 somewhere in my point. Down here, okay, I end up with some negatives. And so that's going to end up making things a little bit crazy. So I know I'm in quadrant 1 because my value is positive. So I'm either at 60 degrees or 30 degrees. Well, you now essentially have to work the problem backwards. Because remember, tan is sine over cosine. So, and I'm looking for my theta. Well, if I start testing out my 60 degrees, I'm going to end up with the square root of 3 over 2 over 1/2. Multiply by my reciprocal. Those cancel. And actually, I get the square root of 3. So I know that that happened at 60 degrees. Or pi over 3. If I tested the other one first, I would get 1/2 over the square root of 3 over 2. Well, when I multiply by my reciprocal, my square root of 3 is in the denominator, and that's not going to work. So, I know that I had to check the other one. Now, where is the tan equal to -1? Well, my first instinct would be, looking at this quadrant, would be to think that it would happen either here, or here, or here. The problem is, though, when I start doing sine over cosine, I have these zeros. So if the cosine is 0, it's going to be undefined, which takes out pi over 2 and 3 pi over 2. Over here, I get 0 over 1, which is 0, so that's still not helpful. But I know I need a -1. So I start looking, and when I start dividing these, like square root 2 over 2 divided by the square root of 2 over 2 is 1. But I need a negative, so now all of a sudden I'm down here. And my answer is 7 pi over 4, or 315 degrees. So with tangent, you got to do a little bit of extra work on the back end to figure out which way you're going. Here are 2 student examples. Go ahead and pause the video, and then come back and check your answers. Go ahead and check your answers. Now, for inverse tangent, remember, it's positive, so we are looking up here in quadrant 1. This one has square root of 3 over 2. This one has square root of 3 over 2. But when I go ahead and do the problem and I end up with square root of 3 over 3, it had to happen at 30 degrees, or pi over 6. For the second one, I get sine negative square root of 2 over 2. Remember, sine lives in quadrant 1 and 4. And is negative in quadrant 4, so go down here, here's my negative y coordinate, and that happened at 315 degrees, or 7 pi over 4. Now, next, evaluate with a calculator. You need to make sure your calculator is in the correct mode based on the directions in the problem. So, you're finding the measure of the angle in degrees. Your calculator needs to be in degree mode. We sort of touched on this in certain classes in section 4.2. We did not in others. So there is a separate video posted at eChalk that shows you exactly how to do this on your calculator. If you are with Ms. Dvorak or Mr. Luke in class, we will also show you how to do it on your calculator. But now the expectation is that you will be able to do this without help and understand when your calculator needs to be in degrees or radians. Now, how do I know? I read the question. This one says, find the measure of the angle in degrees. So, find the measure in degrees. Make sure your calculator is in degree mode. And then you're literally just typing these in your calculator. Arc sine is the same as sine -1, 0.717. It's just a change in vocabulary. Type it in your calculator. Give me the answer. So if you go through the calculator, make sure you're in degrees, and you answer the question, you get the following answers. Inverse sine of 0.717 is 45.807 degrees. Inverse tan. There you go. Now, change your calculator to radians, following the steps, and check the answers. Notice you'll see a difference in the radian and the angle measures. Like 0.799 does not make sense as it measures in degrees. That 45.807 makes sense. So, sometimes you can tell on your calculator if you are in the right mode just by doing the problem. Here are some student examples. Go ahead and practice switching your calculator back and forth. And pause the video now. Come back, check your answers. Go ahead and check your answers. Make sure for degrees that you put the degree symbol. For radians, we assume it's radians. If there is nothing, you can write radians if you would like. Not going to be picky about that, but if it's in degrees, you do have to have the degree sign. Now, composite functions. Just like we did composite functions before, we got to find the value of the inside, then compute the value of the outside. So, I'm looking for the inverse cosine of the square root of 3 over 2. I know, based on how I did my problems before, get out my unit circle. Cosine lives in quadrant 1 and 2. So I go to quadrant 1 and 2. It's positive, so I need a positive x at square root of 3, which is 30 degrees. So now my problem becomes, what's the sine of 30 degrees? Well, the sine of 30 degrees is 1/2. So I figure out the inside, and then I plug that solution in, and I find the outside. So cosine of 5 pi over 6, the x-coordinate at 5 pi over 6 is negative square root 3 over 2. So I'm looking for the inverse cosine of negative square root 3 over 2. Well, as I just said, that happens at 5 pi over 6. So if I have the inverse of the original or the original of the inverse, I know it's going to be whatever I have here. But figure out the inside, then plug it into the outside. Work from the inside out. Here is your homework for today. There are 2 parts. Remember, we started the day with the last kind of little section in 4.3, and then we jumped to 4.7 and talked about inverses. You will have a test next class because it'll be finals day, so please make sure you are ready and have studied both sections for your test. Thank you.